for chapter 8, and this is really the last big algebraic concept that we are going to do in Algebra 2. As I've been saying, we're going to kind of switch gears the last 6 weeks of school, and we will look at a couple of different types of math. We'll still be using algebra, but they're not truly considered algebraic concepts of math. So we have two terms up here that we're going to define. The first one is cross-multiplying, and cross-multiplying is a method. So a method used to solve rational equations when each side of the equation is a single expression. So that's the condition. Oops, and I missed the word each. Let's squeeze that in here. That's important. Each side of the equation is a single expression. So cross-multiplying only works when my problems are set up like example 1. So if you look at example 1, each side of the equation is a single expression, meaning you have one fraction equal to one fraction. So I have this whole entire combined fraction that's considered one expression. An expression is separated by an addition or a subtraction sign. So I have one fraction here. So think about that complex fraction, how we had a couple of fractions in that fraction separated by a plus or minus sign. So we use cross multiplication to solve a problem when we have a single expression on each side. The second vocab term we have here is extraneous solution, and we've been using this one a good bit. Does anybody remember what an extraneous solution is? So we did extraneous solutions with logs. We did extraneous solutions with radical equations in chapter 6. We did extraneous solutions with some quadratics in chapter 4. Ava, what's an extraneous solution?
Isn't it when you get an answer, but if you put it back into the problem, it doesn't work out?
Yeah, nice. So she said you get an answer, and sometimes you get two answers and one of them doesn't work. Sometimes you get one answer and that answer doesn't work. So an answer that does not work when substituted into the original problem. And there's different reasons why it might not work. So with logarithmic equations, it didn't work because you cannot take the log of a negative number or the log of 0. So when we dealt with log equations, an extraneous solution occurred when the value we found for x made the log 0 or negative. When we were dealing with radical equations, so square root, cube root equations, specifically the square root, the answer was extraneous when it kept the square root having a negative number underneath. So that was the condition for extraneous solutions with radicals. When we're dealing with fractions, an extraneous solution is going to happen when the denominator is 0. So if you have an answer that makes the denominator 0, that is an extraneous solution because you cannot take a number divided by 0. I can't take 8 divided by 0, 7 divided by 0, 6 divided by 0. We can't divide by 0. We know that doesn't exist. So that is when an extraneous solution occurs with fractions. So anytime a number that you get makes the denominator 0, then it's considered extraneous. So again, it doesn't matter that x is 0, it's when you plug it back into that problem that makes it 0. So let's look at these first two examples. We're going to use cross multiplication. Cross multiplication is like really quick, easy, simple, straightforward. You're going across the equal sign in a diagonal form. So we're taking the 20 times the x minus 2. I'm going to write this step. You don't have to. But the biggest mistake that I see is that students only multiply 20 times x. And that 20 has to get multiplied by the quantity x minus 2. And then you still have your equal sign. And then you have the other diagonal of 5 times the quantity 2x minus 5. So again, that numerator must multiply by all of the denominator. And then you solve for x. So get your x's on one side, take the 40 to the other, divide by 10, and then don't forget to simplify. So I have 15 tenths, divide those by 5, and I end up with 3 halves. So a real quick check here. After you find your solution, you want to take that solution and plug it in for x. So an extraneous solution is an answer that does not work when substituted into the original problem. In our case, it's when it makes the denominator 0. So make sure you plug that number back in to your original problem and check that it does not make any denominator 0. And if I plug in 3 halves, 2 times 3 halves is 3, minus 5 is negative 2. On the other side, 3 halves minus 2 is negative 1 half. So it's not making the denominator 0. It is a solution that checks out. So see if you can do letter B here. So again, we're using this cross multiplication. So Brooke, what do you get when you take the top left times the bottom right?
Okay, wait, hold on. I gotta do, okay, 4x plus 20.
Okay.
Would the next one be x squared minus 1?
And
Oh,
how
is
did
that-
you get that?
I don't know. Well, when you like factor x squared minus 1, you get x plus 1 and x minus 1.
Uh-huh. Yeah. So when you're multiplying the top right times the bottom left, you're really taking x minus 1 times x plus 1. And Brooke FOILed those together. So we have x squared minus 1. So you have two quantities that need to be multiplied together. So if you need to write that step, then make sure you're writing that step. But you're multiplying both those quantities together by using the FOIL process. So now we have 4x plus 20 equals x squared minus 1. Thinking about the next step here, setting it equal to 0, because there is an x squared term, right? Here's my x squared. So once there's an x squared in the problem, we're going to have to set this equal to 0. So we have x squared minus 4x and then minus 21. So Valerio, what would you do to solve this type of problem?
You would, use AC grouping.
Yeah, so what two numbers multiply to be negative 21 but combine to be negative 4?
-7 and 3.
Yeah. And because the coefficient in front is a 1, we can just take those two values and place them right in factored form. That's the short form when the coefficient is just a 1. And then solve for both. And you have your two solutions. So now we have two solutions. So again, do a quick check. Plug in the 7. 7 plus 1 is 8. 7 plus 5 is 12. It must keep the denominator from being not 0. The denominator can't be 0. And then if you plug in the -3, -3 plus 1 is -2. -3 plus 1 is +2. So both of those would be solutions, no extraneous solutions there. So there are two problems at the bottom. See if you can do those two independent practice problems, and then we'll talk about the next way that we can solve these equations. So solve the following using cross multiplying. Make sure that you check that solution into the original equation. So Ava M, when you're ready, if you could tell me what you have when you use cross multiplication, the expression that you end up with.
I got the expression 6x plus 12 equals 9x plus 24.
Nice. And then when you got your x on the left and your number on the right, what did you end up getting?
I got 3x equals -12, so then x equals -4.
Perfect. Nice job. And checking that back into the original problem, just give a quick check with that denominator, -4. Plugging it into the original problem, we end up with a -2. That one works out, and then we end up with a -4 on the other side, -12 plus 8. All right, so then looking at number 2, Grace, do you have number 2?
I haven't fully finished, but I have part of it done.
Okay, well, give me that first kind of long equation form.
All right. I have -6 parentheses x minus 1 equals -12 parentheses x plus 2.
Good. And then if you distribute -6 and -12 through, what does that make, Grace?
-6x plus 6 equals -12x minus 24.
Perfect. Nice job. Good. So I'm going to add the 12 to the left, giving us a positive 6x. Subtract the 6 to the right, which makes a -30. And then x is -5. And again, just doing a quick check. If I plug in a -5, -5 plus 2, -5 minus 1, our denominator is not 0. So all of these were solutions. None of them contained an extraneous solution. Are there any questions with cross multiplying? So cross multiplying is pretty straightforward, but it only works when you have one fraction on the left and one fraction on the right. That's the condition that must be met for cross multiplication. That is only going to be a handful of equations. If you look at the next problem, example 2, the left side has 2 fractions. So I no longer can use cross multiplication because the left side of the equation is 2 fractions. Now, there are multiple ways to solve this type of equation. There's a little hint provided that says multiply each side by the least common denominator. I like to work through this problem to get it to look like this step right here, so that we don't have fractions remaining in the problem. And that's what cross multiplication does for us. It takes the fractions out and it makes this form in this horizontal, like the equation being a horizontal form, which is how we solve an equation. So we're going to use the least common denominator to help us eliminate the fractions from this equation. So in one step, we have 3 fractions, and then the next step, we should have no fractions in the equation. So let's start with the least common denominator first. If we look at these fractions, Jordan, what would the least common denominator be of all 3 fractions?
Would it be 3x?
Yeah, 3x. So we're going to multiply each side by the least common denominator. We just got done talking about the least common denominator. So I'm going to now kind of think of it a little bit like we did with the complex fractions in a way. So multiply this side by the least common denominator. And I'm just going to place that over 1 just so that it looks like a fraction. And then I'm going to multiply the other side by the least common denominator. So the goal is to not have a fraction in the next step. So if I look at the first fraction, it is 8 over x. It has an 8 in the denominator, or I'm sorry, an x in the denominator. So Jordan, what would the numerator need so that it has all of the least common denominator?
You'd have to multiply it by 3.
Right. So the way this works is we are going to multiply it by 3. The x is going to cancel out because my x will cancel right here as well. So really, we're taking this least common denominator and we're distributing it to both parts of the equation so that we no longer have the denominator. So we're going to have a 24 because 8 times 3, I needed to multiply by 3. That was the missing piece that wasn't in the denominator. So if you look at the next one, let's put a plus sign down here first. The next one has a 3 in the denominator. Jordan, what would the numerator need?
An x.
An x. So the 3 is also gone because it really is canceling with that 3. And now we just have 11x. So by multiplying with the least common denominator, the denominator completely cancels from the problem. And we're left with 24 plus 11x. Now this only works when it's an equation because you're doing the same thing to both sides of the equation. It doesn't work when we have an expression that you're just adding because the least common denominator has to be with those 2 fractions because you're not solving and you're not doing something to the same side of the other equation or the other side of the equation. So the last part, if I look at the other side of the equation, it has an x. The x cancels, but it needs the 3. And negative 14 times 3 makes negative 42. So think of this as the denominators totally go away. The current denominator is gone. The extra piece that the denominator needed is what we multiply the numerator by, which is exactly the same process that we used when we were adding and subtracting fractions. except we kept the denominator because we were adding and subtracting by finding a least common denominator. Now we're allowed to eliminate the denominator because we're doing the same thing to both sides of the equation. So the denominator is canceling because it's an equation. Questions on how I have this 24 plus 11x equals negative 42? All right, so then if you go to solve this, I now can solve exactly like we did above. So we have a fraction. We got rid of the fraction this time by using the least common denominator. And we would subtract 24, which makes negative 66, and divide by 11. And you get negative 6. As always, just make sure that negative 6 doesn't make the denominator 0. And it's just an x, so it's not going to make that denominator 0. So we're going to practice this process a few more times so that everybody feels a little more comfortable with it. It is a little different. We are using the same process of a least common denominator. So the numerator part is the same way we found a least common denominator by adding fractions together. So let's look at the next problem. And we're going to see if we can use this same process. So the first thing I'm going to do is I'm going to place that 2 with a 1 underneath, just so that it looks like a fraction. All right, so least common denominator here. Faith, do you know what the least common denominator is?
X plus 3 and x minus 4.
Yeah. So both of those factors, x plus 3, x minus 4. So it says to multiply both sides by the least common denominator. So because we're multiplying by the least common denominator, that's a minus 4. And we're doing it to both sides, we're able to get that denominator to cancel out. So Faith, on the left side, what term are we going to multiply the numerator by?
X minus 4 times 3x minus 5.
Nice job. So there is a 3x minus 5, and she said we need x minus 4 there. So I'm going to write exactly what she said down. So there's a 3x minus 5 in the numerator currently, and we're going to multiply it by x minus 4. And then we have our equal sign. Faith, how about the 2? The 2 only has a 1 on the bottom. So what is that 2 going to be multiplied by?
Least common denominator.
Yeah, exactly. Yeah. So the whole least common denominator, because it doesn't have any parts. So we have the 2, and then the x plus 3, x minus 4. So the entire least common denominator. And then finally, Faith, what about that plus 18 over x plus 3, x minus 4?
You do nothing to it.
Nice, you do nothing. It just stays as 18 because it has the whole denominator. It has the exact same least common denominator. So all of that's canceling. So again, exactly the same as adding or subtracting expressions, except because it's an equation, the denominator can cancel. Questions with the step here? Faith, you did an excellent job. Nice job. Please ask questions if you have any. All right, so this problem now looks like a pretty involved algebraic problem. Gabby Soul, what do you think you're going to have to do at this point of the problem?
Would you have to distribute the 2 into the fractions? or the, gosh, I forgot the word.
They're good. So she said, would you have to distribute the 2? Yes, we're gonna have to distribute the 2. What else are you gonna have to do, Gabby?
Would you have to multiply the left side together?
We're gonna have to do both of those. Yeah, so we're gonna have to do a lot of multiplying here. So multiply the left side together using a little FOIL. So this, as I said, this chapter kind of pulls together all of that algebra that we have been working on, and all of the concepts that we have been doing get kind of pulled together in this chapter. So we have a 3x squared, and then there's a -12 and a -5, so that's a 17x that's negative, and then plus 20. And then we have that equal sign still. So when you distribute the 2 through, I'm going to just kind of show a little extra step here. The 2 only gets distributed to the quantity it's sitting next to. So this becomes 2x plus 6, and then it's still x minus 4. There's only 1 2, and it's sitting next to x plus 3. So that becomes 2x plus 6. So then FOIL those 2 together. We distributed 2. Now we're going to FOIL. And that gives us 2x squared, like a 2x and a -24. And then that plus 18 is still in the problem. And I think this is a -2. Got to watch my sign. There we go. All right. What do you do next? Ella, what do you think you would do next?
Move the terms on the right to the left.
Yeah, and we try and keep that x squared positive. So she said exactly the right thing, or the correct statement. So we're going to subtract 2x squared, add 2x. Line up your terms. Add 24, and then subtract 18. So kind of line everything up as you're taking it to the left side. And Ella, I'll give you a couple of seconds here. When you combine all your like terms, let me know what you get.
I got x squared minus 15x plus 26 equals 0.
Nice job. So Ella, after all of that moving terms, the last part to solve this is what?
Factor it.
Yeah, so we're looking at 26. What two numbers multiply to be 26?
-2 and -13.
Nice job. Again, this is the quick factoring. You don't have to go through the whole grouping process. Anytime there's a 1 in front, it's the short factoring. And then solve. And we get a 2 and a 13. So finally, just make sure, I'm going to go back to the original problem, cancel out my stuff here. Please don't forget to check for extraneous solutions. And that means that you need to check the 2 to make sure that it doesn't make the denominator 0. So 2 plus 3, 2 plus 3, 2 minus 4. None of those become 0. And the same thing with the 13. If you plug a 13 in, all of those 13 plus 3, 13 plus 3, 13 minus 4. So none of those make the denominator 0. So this would be our solution. Any questions? So we are going to actually skip the independent practice. We're going to do those 2 at the start of class tomorrow. But I want to look at example 4A, and we're going to end the class with this last problem here. So looking at the 3 denominators, before you find the least common denominator in this problem, what's the first thing that you must do before getting a least common denominator? So there's one step that has to be done first. Malachi, what do you think?
Factoring.
Yeah, which one needs factored?
X squared minus 16.
And how would it factor?
X plus 4 and x minus 4.
Nice job. So factor first. And then Malachi, what is the least common denominator now that it's factored?
X plus 4 and x minus 4.
Yeah, it kind of works out nice because if you look at the left and compare it to the right, we have that x plus 4 and x minus 4 in two separate fractions. So factor first, and that's what you need to do for any problem where you have to find the least common denominator. Your denominators must be factored. So take both sides of the equation. That looks ugly. Try again. That's a little better. Multiply by x plus 4, x minus 4. And multiply by x plus 4, x minus 4. So the reason the denominators cancel is because you're multiplying by the least common denominator. So that's why they are canceling. So in this first fraction, our denominator is the least common denominator. So it's just going to be a 6x squared. Jaden, what happens with the middle fraction, the 3x over x plus 4? What would it need?
So it would need multiplied by x minus 4, and you
Okay.
would get
You know what? I'm just going to write it down right now. So there is a 3x.
sorry.
No, it's okay. And then it's x minus 4. No, you're fine. I just want to write it down. And then Jaden, how about on the other side of the equal sign?
You would need to multiply 4 by x plus 4.
Excellent. So we have the 4 and then the x plus 4. So I kept the original equation. Here's the original parts. And then those original parts were multiplied by whatever was missing from the least common denominator. Make sure you're noticing it's a minus 3x. So be really careful. All right, Jaden, when you distribute, you were going to give it to me and I stopped you. What do you get when you distribute through?
So you would get negative 3x squared plus 12x, and then you would get equals 4x plus 16.
Nice job. Good. All right, so everything is factored. Set this equal to 0. We have to subtract a 4x and subtract a 16. Also subtract those like terms. So 3x squared, 8x minus 16 is equal to 0. So Gabby Soul, I'm not picking on you, but from yesterday, how would you factor this problem?
Okay, I forget the name of it, but wouldn't you multiply the 3 and the 16 together?
Yeah, so that's the AC grouping. So 3 times 16. Is that a negative 48?
Yeah, I think so.
All right, and we want two numbers that multiply to be 48, but combine to be 8.
Would it be 12 and negative 4?
Yeah, nice job. Good. So after you take that 12 and negative 4, this is where you expand the problem. And Gabby, what do you do once you expand the problem? Does anybody know what you do from this point? We have it expanded using that 12 and negative 4 that Gabby gave us. What do we do next? Grace, what do you think?
Is this where you would like group the first two numbers together and the second two? So the first two, you could pull out a 3x and then you'd have in parentheses x plus 4. And then the second one, you could pull out a negative 4 and you'd have x plus 4.
Nice job. And then if we pull them together, we have it factored. Set it equal to 0. And I have a factor at 4/3, or a solution at 4/3, and a solution at -4. So that's the AC grouping process. That's a big problem. The very last step, it says check for extraneous solutions. So I'm going to come back to my original problem. Plugging in 4/3 doesn't make the denominator 0. However, if we plug in a -4, -4 squared is 16. 16 minus 16 is 0. -4 plus 4 is also 0. This is our first problem that has an extraneous solution. It works on the other side when I plug in a -4, but it doesn't work for 2 of the fractions, and it's actually just 1. Once it makes one fraction 0, it's an extraneous solution. So make sure that you plug in that solution and check the denominator. So once it's extraneous, we cross it off. This guy is extraneous. So again, homework tonight, the first group of problems, 1 through 10, is cross multiplying. And then 11 through 19 odd, you'll be using the least common denominator to solve. Make sure you check for extraneous solutions. And please make sure you show your work. If you have questions, you can feel free to remain on. Otherwise, have a fantastic day and see you all back in the classroom tomorrow.
Have a good day.
Thanks,
Great
you
day.
too.